Hi, everyone. I am really glad to be here. I'm a little sad that I can't be at ChefConf London this year, but this will definitely have to suffice. So today I'm going to be talking to you about shifting security and sanity left by testing Terraform with InSpec. And if you hear scuffling, my dog is right there. So we'll just deal with it. This is better than her barking at the door. Okay, so I'm willing to bet that many of you have been on projects where the temptation or even the expectation from leadership was just to go fast and deliver as quickly as possible, because that's what we do, right? And then testing was seen as maybe an extra or something that maybe you would add on later in slower sprints. And I know this is true because I've been on multiple projects like this, and you feel torn because you know that implementing testing would make your life a little bit easier, but you get pushback from it. They say, what, we test, we run Terraform plan, or, you know, we run Terraform output afterwards, so we know what was created. Isn't that a waste of time to do anything sort of extra? And my argument is, you never know what's really going to happen fully until you run Terraform apply. I'm gonna take my dog's bone away from her because she's being very loud. So maybe you are one of those people that can look at the plan and know exactly what's gonna happen with Terraform apply. But what if somebody else, well, and I might argue that maybe you don't, and you think you do, or also maybe somebody else is gonna be working in your module and they really aren't super familiar, but they just needed to make this little change. So running a plan or an output later is not enough necessarily. So maybe maybe this has been you. You've rushed to get this Terraform project finished, and then later on, maybe a month or two later, everything is implemented, everything is running smoothly, except when you need to make a change and you're stuck in this bottleneck of manual testing or bugs that you don't know where they're coming from or whatever, and you realize then, oh, you could have done so much more in the beginning to save your sanity later on down the road. So trust me, your future self and your future teammates will thank you for implementing testing early on, because the earlier we can do this, the more we can shift it left, you know, the easier it makes it for everybody. You might also be asking, aren't there better Terraform testing methods than InSpec? What about TerraTest? What about, I don't know, just running, if you're in Azure, what about just running a bunch of AZ CLI commands to make sure that your stuff is there? Whatever you do, it just depends. Just do some testing for sure. But also, I don't think, number one, I don't think TerraTest actually tests the infrastructure. Could totally be wrong, don't know about that, but I know the InSpec does. Like it might just be linting and whatnot, but I'm not sure. But also, you're here at ChefConf. You know InSpec already. You know Ruby's already installed on your workstation. The barrier to entry is low with InSpec, so you're already doing it. So why not use something that you already know? If you're stuck in fast mode and you wisely know that you really do need testing, then using whatever is easiest for you and your team to onboard onto is really key in getting these tests into the pipeline quickly. So I am Annie Hedgpeth, and if you didn't realize yet, my main job includes configuration management and infrastructure as code development. And I'm a cloud automation engineer at 10th magnitude. I use Chef and InSpec for configuration management, mostly. For infrastructure as code provisioning, I like Terraform most, and that is what I tend to use most. Azure is my cloud provider of choice because I work for an Azure consultancy, but everything that I'm doing here in this talk can be done in any cloud, on-prem, whatever you want. All right, so I titled my talk as such because I'm going to be walking you through some of the following use cases for just how you might shift security and sanity left by testing Terraform with InSpec. So the first thing that we're going to talk about is basically just production provisioning validation. Oh, hi, girl. Let's let her go outside. Okay, go. You have fully provisioned an environment, and you want to validate that it is in the desired state. So you use InSpec for that. It's a great use case. Second use case is test-driven development. You are in the process of developing this module, and you're making changes daily, tons of them, and you want to write a test, watch it fail, and then write the code to remediate that failure. Third thing, integration testing and CI/CD. You can use InSpec and Test Kitchen for a CI/CD pipeline by oh, she wants her bone, that's what she wants. This is the weirdest ChefConf talk I've ever given. Okay, the next thing, my kids are gonna come in screaming, so just wait. CI/CD, you can use integration testing in a CI/CD pipeline by running tests at each pull request and not letting it merge into master without passing your Test Kitchen build. And lastly, you can add all of your compliance testing to these early on test builds so that you don't find out way too late that major changes are required for the sake of security and compliance. All right, so you're at ChefConf, you know what InSpec is, most likely, but let's just say there's a few of you here that might be new to it, and I am going to give you a very quick crash course on what it is. So InSpec is a framework for testing and auditing, basically. You're going to use it to define your desired state and to define the desired state of your applications and infrastructure. And what it's going to do is it's going to actually compare the actual state of your system to the desired state that you expressed in your code. It's going to detect the violations. It's not going to do anything about the violations, but it's going to tell you in a report, and it puts you in control of the remediation. And kudos to you if you deduced why my son's foot is in that picture with a sock tied around it. So I told him the desired state of getting dressed for school in the morning was to put his socks on. And he did, in fact, put his socks on. But as you can tell, I didn't clearly enough define the desired state because obviously they should have been put on in a different way. So make sure you clearly define all of your desired state, or else who knows what can happen. And InSpec profile is built kind of like Chef Cookbook. So you've got your profile, which is like your cookbook. You've got your controls, which are like recipes. And then you've got your tests, which are like resources. And it's nested just like this. And this is an individual test. And then if you zoom out a little bit, you've got tests that are nested within a control. So you can have as many tests as you want in a control, and a control sort of depends on what you want it to be. It can be any sort of grouping of tests that you want it. And then within that control also, you've got some metadata that's really useful because different teams can use that for making it all make sense to them. That metadata is really helpful for testing compliance because you can also map it to specific audits and whatnot. All right, so again, I hope this is not too fast, but if you are more interested in InSpec and you don't know a lot about it, there are a lot of talks out there for it. So I highly recommend digging into that if you're not super familiar. But this is the structure of an InSpec profile. You've got your profile. Within it, you've got a controls directory with your controls in it. Libraries just if you need it, if you need to create extra config files if you need it. But really, all you need is controls and an InSpec YAML. And then you can store this anywhere locally in source control. You can store it in the chef supermarket and automate. Very versatile, so you can call it from wherever you're at. Okay, so remember the first use case I talked about was using InSpec to validate a production deployment. So one way of doing this and I'll tell you a couple different ways, but one way of doing this is just to simply use a null resource in Terraform and use the local exec provisioner and just run InSpec, the InSpec executable straight from there. So you've, inside your module, you've provisioned everything, and then now it's telling you whether or not it's in desired state. Couple of problems with this. It's not great to rerun. Like, it's great if everything goes right, but running it over and over is not super fantastic because of the way that Terraform handles errors and keeping things idempotent. So it might be good for a production validation, you know everything's going to go well. It might be good for compliance auditing because you can tack on a compliance profile that says, hey, look, security and compliance team, we just created this environment and it is in the desired state that you want it to be in security wise. So there you go. But the problems with it is that for developing for sure, it's just way too cumbersome to use. But also, you might just also think about taking it out of the null resource and just putting it in the pipeline. Like you run have it as a separate task in your pipeline as opposed to putting it in Terraform. But this is possible if you want to do it. It's kind of cool to see happen. All right, so the second, something that I like using a little better is Test Kitchen. So this is the second and third use cases that we talked about. So Test Kitchen is not just for Chef. You can definitely use it for Terraform. And what's really cool is that this is being maintained by New Context, and it's pretty well maintained and kept up, and it works fantastic. It's a nice little sandbox that sort of provides the perfect little isolated sandbox to do test-driven development with. So in the same way that you can use Test Kitchen as a sandbox for your cookbooks, this is a sandbox for your entire environment of infrastructure that you're provisioning. And you would use the Kitchen Terraform driver. A side benefit of this is it's a great tool for onboarding, because let's say that you've got new team members to your team and you've got this very complex Terraform module hierarchy and whatnot and structure. Well, if you use Test Kitchen, you can show them in a nice isolated sandbox again what it's doing and how it's working. You can build an entire module from your Test Kitchen and go into your cloud provider's portal and show them exactly what it is. You can really learn it without affecting other things. So let's go through this and see what I'm talking about. Okay, so the Kitchen Terraform driver is what's going to be used to create all of the resources. And what it does is it provides a set of Test Kitchen plugins which enable a system to use Test Kitchen to convert a Terraform configuration and verify the resulting Terraform state with InSpec controls. So it's basically just using, it's built with Ruby, it uses Bundler, and it uses the gem Kitchen Terraform, and it's using Terraform under the hood to obviously provision the things, and then under the hood for the kitchen verify, it's using InSpec. So again, if you're familiar with Chef and Ruby, you've already got all this installed, and so it's really ideal for you. If you're not, then I could see that being more of a challenge, but I still think that the benefits outweigh the onboarding to it. Okay, so that's my kitchen, by the way, but it's not all black and white like that. But anyway, the way the kitchen works is that you basically nest, or I'm sorry, the way that Kitchen Terraform works is that you basically nest your own Test Kitchen module inside of your module that you're testing. So the installation inside of this nest sort of makes it its own environment. So let me show you more about that. All right, so here, this is what your regular module that you're testing looks like. You've got your README, you've got your outputs, your TF-vars, your variables, and then your Terraform file that's actually doing something. So that would, in this case, it would be the vm.tf. We're just going to create one VM. And this is the test directory that's nested inside of it. And this is where you'll have all of your fixtures and your integration tests. So your fixture is your test module. And right here in your main.tf is where you are going to basically wrap the module that you're testing. So this is what it looks like inside the main.tf. And you can see it's just wrapping the root module. And this is called, the root module in this example is called Test Kitchen Terraform, which admittedly is a little confusing. But you're able to give it its own variables right here too, which is cool because you can keep it separate from the main module's variables. And it's running just like you would run a module in anything. And then you can also insert any dependent resources here. Let's say that there's a VNet that already exists and you want to have that exist before you run your module. Well, you can put that there. Or it could be anything, a key vault, a storage account, SQL database, whatever you need that already exists that your module depends on, just create it there in your test kitchen module, and then you don't have to worry about interfering with already existing resources that maybe you don't want to interfere with if it's just a development test kitchen instance. Okay, so here in the integration folder, you've got all of your InSpec controls, and let's see. So each of these, your entire InSpec profile is going to be nested in there, and within that, you can also depend on other InSpec profiles if you so desire. And also, this is important to note, the kitchen YAML is not inside the test directory. It's at the root level of the module that you're testing. So make sure that that sits up top. And this is what your kitchen YAML looks like. It looks very similar as if you're doing a cookbook test kitchen. So here you have your driver, and the Terraform driver is what manages the state of the Terraform root module. And you can see here that the root module is directed to be the test kitchen that's nested inside the fixtures directory. And the Terraform provisioner is what uses the Terraform driver to apply the changes to the Terraform state. And then here, the Terraform verifier uses InSpec to verify the Terraform state. And a kitchen instance is verified by iterating through the systems. So if you'll notice here, we've got two different systems. And this is what's really cool. This is probably my favorite part about the Terraform, the kitchen Terraform driver, is that you can audit both the resources in your cloud, like your actual infrastructure resources, and you can go inside the VM and audit or validate that your VM is in desired state. So let's say that you did a Chef bootstrap during your Terraform module, or let's say you did a Cloud Init script that you applied during your Terraform provisioning. Well, this way you can use InSpec to validate that all of that happened the way that you want it to. All right, so I told you that you can test two different systems. I told you the system being the VM and the actual subscription, or targets as InSpec calls them. So in InSpec right here, you can see that our two different targets might be Azure and Linux. So first, make sure that in your InSpec config, you're supporting all of the systems that you're testing. So if you're going to test both VM and Azure, then make sure that you support them both in there in your InSpec YAML. And then here in the InSpec profile controls directory, you can see that we lumped both of the systems tests into the same profile. But InSpec is definitely going to fail if you have controls in an InSpec run that aren't for that target or for that system. So then go back to your kitchen config over here and make sure that each system is only running the controls for that particular system. So you see right here, we have an array of the controls that we're running. And in the Azure system, we're only running the resources controls. And in the VM system, we're only running the VM configs controls. And another consideration that I don't have time to explain here, but that you can do some further reading on, is profile inheritance. And this is the way in which you can run other profiles from this profile. And that would be done through the InSpec YAML, but I suggest further reading upon profile inheritance if you get a chance. Okay, so now here is the fun part. So you can start using, or you can start running Test Kitchen and getting your sandbox up and testing if you know how it works in practice. So the first two commands that you will use with Terraform, with Kitchen Terraform, map directly to Terraform commands. So Kitchen Create is going to map directly to Terraform init, and then Kitchen Converge is going to map to Terraform workspace select, get, and validate, and then Terraform apply. So I don't know. I'm a little torn about this because I kind of want Kitchen Create to run Terraform init and Terraform plan, but it doesn't, and I'm sure there's reasons for that, but I still don't get it, but I wish it did. But then I guess it would also have to do workspace select, get, and validate. But anywho, but you just have to know that that's the way that it does it. So whenever you run Kitchen Converge, it's going to automatically do an apply, and you need to be ready for that. It's not going to give you a plan. It's just going to go straight for the apply. So then to run your tests, you're going to run Kitchen Verify, and that just runs the InSpec executable against the targets. And then just like you would expect, Kitchen Destroy deletes all the resources using the TF state file that is in the test directory, not inside your main modules directory. So no worries there. Okay, so now's our time. Now it's time for the fake demo. I'm just going to walk you through some output. All right, so this is what our Kitchen Create is going to look like. And you can see here that I am running it inside Ruby's bundle exec, and I'm running it from the main module's root directory, not the test directory, which is admittedly confusing since my root module is called Test Kitchen Terraform. So sorry about that, but there you go. All right, so bundle exec, Kitchen Create, and that's running Terraform init. As you can see here, it's just a wrapper around Terraform init, which will initialize a working directory containing Terraform configuration files inside our test directory. And then after that runs successfully, you'll move on to Kitchen Converge, which you can see here will first run, as I said, Terraform workspace select, which will select that new workspace that we just created in our test kitchen directory so that we can do stuff in it. And then it'll run Terraform get update to download and update modules mentioned in the root module, which in this case is our test kitchen module. And then here, Terraform validate to verify that the syntax is good and that the variables work and all that good stuff. And finally, it runs Terraform apply, like I told you, all in one fell swoop. And it runs it from that same test directory. And it starts provisioning a test kitchen environment of our root module. So you can see here, it is go into work creating those resources in Azure. And then if we scroll down, we can see here that it finished and it gave us our Terraform output, of which I didn't output anything. Oh yes, I did. Resource group, VM, public IP address, etc. 10 resources created, 0 changed, 0 destroyed. So then if we, no, next one. So then my favorite part, because it feels so good to know that everything happened the way that you wanted it to, we're gonna actually validate our modules. So here we're running kitchen verify. And remember that's gonna run InSpec against the 2 different targets that we gave it in the kitchen YAML. So remember our 2 different targets were the VM and the Azure subscription. So first here, it's gonna run all of the VM config InSpec tests against the VM target. So now we have validated, so you can see here we validated that let's see, TK user home is expected to equal home / TK user. The directory exists, the owner of that directory is good. So that is all good. And again, you can do this. You don't have to use Chef to create that config. InSpec doesn't care. You can use Ansible, DSC, Cloud Init, whatever you want to create that config. InSpec just cares that it is in the desired state that you defined in your InSpec profile. All right, so next we are targeting the Azure environment itself, as I said, and we're validating that all of the resources that we created exist. So here we can see that the VM exists and there's network security groups and rules, and that the virtual network that we created exists. It's all in the region that we wanted it to be in. And you can make this as complex as you want to be. This is a bare bones module, so it's just doing just a little bit of stuff, but this can be as verbose as you want it to be. Also, you can you're not limited to the tests that already have resources created for them in InSpec. If you need to, you can create either custom resources and make your own, so that you can, I don't know, if something is more complicated than this, you can create your own, or you can even use well, for Azure, you would just use the command line to either AZCLI or PowerShell to validate that resources exist. However, you would have to, that's for another topic, but it can be done. Okay, so after you're finished and you have run converge and verify as many times as you needed to, you can then destroy your test kitchen with kitchen destroy. And this will again select your test workspace. So don't worry, you're not destroying anything that you don't mean to be destroying. You were keeping it isolated, sandboxed, and then it will run Terraform destroy from the safety of your sandbox. And when all is done, you don't have to worry about keeping any of these environments around. Okay, so what just happened? That was a lot of slides, a lot of code that I just showed you. But the good news is you were able to run a Terraform apply to find out what was really going to happen as a result of your changes. You were able to validate that apply, you were able to validate with InSpec that apply did what you expected it to do. You ran the entire Terraform module from the safety of an isolated sandbox, and no other environments were hurt in the making or destroying of that sandbox. So this is really big. You just added trust to your pull requests and approvals, which is really important. So, okay, now that you know sort of the process and everything of what I'm talking about, let's go back to this slide and talk about those use cases again to refresh your memory of what you would use with each. Okay, so remember, for production provisioning validation or compliance and shifting security left, we would use either the local exec command to run the InSpec exec, or we would run it in the pipeline after the fact and not do it in Terraform. And then if you want to use test-driven development practices in the development of your Terraform modules, then use those tests in a pull request build, then Test Kitchen will be your friend for that. So both of these ways, both of these highlighted ones right here, we're gonna use Test Kitchen for. And you know, you can even add those compliance profiles that I keep talking about in those Test Kitchen tests and pull request builds to make sure that nothing gets merged that would push you out of compliance. Why not do it early in the development process so that you can ensure more safety and security? And that's it. These are the resources that I can direct you to. I really hope that this makes your terraforming more sane and more enjoyable. This is a demo repo in my GitHub, and I also blogged about it there at the second link, so feel free to take a look at those. And of course, you can familiarize yourself with the Kitchen Terraform plugin there on GitHub, see how it works under the hood. And again, I'm Annie Hedgpeth, and here's how you can get a hold of me. And it's been such a pleasure sharing this with you today, so feel free to reach out if you have any questions. Thank you very much.
Awesome. Thank you, Annie. Does anybody have any questions for Annie? While she was talking, I did post some things in the chat for folks, a little bit about intro stuff for InSpec profile inheritance. It's like, how fast can Mandy find links to put in the chat while the speaker is talking? I'm getting pretty good at that now. And there's some other things there. If you're totally new to InSpec, learn.chef.io, there's plenty of stuff there. And there's also stuff on inspec.io there as well. So does anybody have anything else they would like to know about this whole workflow? From a crazy advanced piece of this, do you plug this sort of thing into like workflow and pipeline tooling and all that kind of stuff too?
Yeah, I mean, it's so versatile. You can, wherever you need validation, plug it in, you know, like if you want to, right now we're using Azure DevOps. So for the current project that I'm on, and we just have a pipeline that creates, or that does a Terraform plan and apply. And then after that, you can just stick in either, like I said, put it in the module that runs the InSpec exec, or just run an InSpec exec after that in your pipeline to validate. Otherwise, in your CI/CD, you can, just like you do with cookbooks, you have it run Test Kitchen right after you either push a branch or push a commit, or like before you accept a pull request, before you merge into master, you can have it run a Test Kitchen build. Is that what you were asking, or were you asking something more complex? Yeah.
You know, all kinds of places to plug it in. We got one more from Alan here. Is the sandbox setup being used as a proxy for scanning a production system?
As a proxy for scanning a production system? No. I might not understand the question. Is the sandbox setup being used as a proxy for scanning a No, I might have been confusing you by using sandbox, but to validate your production system that you provisioned, kitchen and your sandbox is totally separate from that. Like, forget about that. You would just run InSpec after the fact. And you could use those same tests that you used in Test Kitchen to validate it later on. But yeah, forget about sandbox in that setting.
Yep. Okay. Gotcha on that one. Awesome. Another one here. This is an interesting question. Everyone should always do your destroy part when they're done. But in the event someone doesn't, do you have any suggestions or tips for guardrails for cost controls around orphan infrastructure if people leave things laying?
Yeah, that can get really annoying. I know this very thoroughly. I would just, so in Azure at least, I would create a policy in the Azure subscription to do a destroy like every night or something of all of the resources that have like a test kitchen tag on them or something, but make sure to tag them in you're usually tagging everything anyway, you know, so in your variables, you would have them tagged something different, you know, like whatever your test kitchen tags might be, and then have a policy that cleans them up every day. That's definitely necessary because people will leave them orphaned, I promise you, and that gets expensive.
Absolutely. We have a whole bunch of things that do weird destroys. And I think someone actually gave a ChefConf talk about it last year for like some kind, we call it Reaper, something like that internally. Just because why not? Another one here. Where does Kitchen run the tests? Vagrant, Kitchen Dock-in, test account in the cloud. You were showing a combination there, right?
Where does it run the tests? Well, I was just, the examples that I showed were just locally. I was just running those from my workstation, but yeah, they can run it on a Jenkins agent, on a Azure DevOps agent, whatever you want. As long as it's all set up with your, you know, being able to talk to your subscription.
Yeah, got your accounts all linked in, all that kind of stuff.
Yeah.
There was a question in the chat about the things that you put in your last slide. I think I caught the links that you had posted there. If you could put those back up for folks for a minute.
Yeah, I will drop them in the chat.
Awesome. Yeah. We got the personally so far my favorite co-presenter. Like that was our first canine guest speakers for ChefConf this year, so that was great.
She's usually so quiet, I swear.
I'm sure. There's something different going on, so it's exciting.
Yeah, she sensed it.
Awesome. All right. Well, thank you everybody for coming. That's great. And don't forget to sign up for ChefConf at chefconf.io. This talk and the rest of them will be available there on demand.
Thank you, Mandy, and thank you, everyone.